Hey guys, this is the high school scientist, and in this video I will be explaining the concept of vectors, scalars and the ways in which they can be used. So let's start by imagining that the government has given you a contract to build a road with a magnitude of 5 kilometers. Now what this means is that you can build a road of 5 kilometers in any direction. It doesn't matter because it's just a magnitude, a scalar value which has no directions. By the way, magnitude is just a fancy way of saying length, and a scalar value is length with no direction. But we all know that the government is made up of smart people, so they will never tell you to build a road with just a scalar value. But rather they will give you a vector value to build the road of 5 kilometers. And a vector is something with both magnitude and direction. Yes, I know math can get a bit tricky here, because it's not possible to specify a direction without a diagram, and some of the questions which you might have to solve in your exams won't have diagrams to help you out. Instead, they will have coordinates which can be hard or more like confusing. Okay, so for example, displacement. It's the shortest distance from point A to point B, and this comes with a direction because it has to specify a connection from point A to B. So displacement is kind of a really good way to think about vectors, as it gives you both a magnitude and a direction. By the way, there are many different types of vectors like parallel, anti-parallel, orthogonal, and as well as unit vectors. Well, speaking of unit vectors, it's just a way of getting the direction without the magnitude. Like you have a vector of something drawn in your book, but you don't care about the magnitude, you only want the direction. So what do? You just take the vector and divide it with its own magnitude. So all you have left is just the direction and a magnitude of 1. Well, these were the technical stuffs. So now that we have it out of our way, we can now focus on how to use this goddamn vector. Let's start with simple addition. Here we have two vectors, let's say A and B, in the same direction. So in this case, we can simply add them together because they are going to be in the same direction no matter what you do. But what if these vectors are in different directions? Now we have to get the resultant of these two vectors. You guys might also know this as the triangle law of addition. This basically means that if we have a triangle with two sides, A and B, then the direction of the third side will be the sum of A and B. But how do we find the magnitude of this third side? Well, it might be a bit confusing because sometimes the triangle is not right angled, so that's why we have to do some extra steps to get the magnitude of the third side. Okay, let me explain. Just take a look at this diagram. Here we have a vector A and a vector B. We have to find the magnitude of the third side. But we have a problem here. As this is not a right angled triangle, we cannot use the Pythagoras theorem. So now we have to convert this triangle into something that we can work with. Like here we have a vector A which we can extend to a point N so that we can have a triangle which is right angled. Now this leaves us with two unknown sides and an angle theta. It's actually really easy to find these two sides, as we know that the opposite side can also be written as B sin theta and the adjacent side can be written as B cos theta. Now we have a right angled triangle, so just by solving the Pythagoras theorem, we get the magnitude of the third side. Okay, now that you understand how to find the sum of magnitudes of two vectors, let's also take a look at how to find the directions in which this vector will be oriented. So earlier I said that the direction will be the resultant of A and B. But that doesn't give us an angle. We need an angle to represent a direction. As in this case we have all three sides of a triangle, we can use simple trigonometry to find the angle alpha which is subtended by A and B. Okay, I know that this was really confusing, so let's just take a look at one textbook example to clear things up a little bit. So here we have a vector A which is 5 units and a vector B which is 7 units. Now both of these vectors are subtended by an angle of 60 degrees. Now you might think that the resultant of these two vectors should be something like this, but that's a really wrong way to assume things, because you have to note the directions in which these two vectors are oriented in. So you can shift vectors in a way which doesn't affect its direction nor its magnitude. For instance, I shift this vector B to a new position. Now the direction remains the same and we have a triangle to work with. Now don't get confused over here. There's nothing wrong in keeping the vectors as it is. It's just that it gets confusing to get a resultant vector in its original orientation. So that's why taking an intuitive approach to solve a problem would help you remember things well. So this shifting of vector B gives us a triangle to work with. And now that we have all the values in the question, we can use the Pythagoras theorem to find the magnitude of the resultant vector, and we can use simple trigonometry to find the angle subtended by this vector. And now we have a magnitude and an angle which gives us a direction of the third vector. So this might have been super confusing for some of you, and if you had no clue about what happened in this video, feel free to ask your questions in the comments below. I'll try my best to answer them. And there is much more to learn, so in my next video I will be explaining how to subtract two vectors and how vectors can also be represented in 3 dimensions. Yeah, that's gonna be hard. So that's it for this video. This is the High School Scientist signing off.